Greetings everyone. Today we're going to discuss the first question, third question, which was asked by the LeetCode in its weekly contest. Okay, the name of the question is find the maximum number of marked indices. Right. So what does the question state? You are given a zero indexed integer array nums, and initially all the indices are unmarked, and you are allowed to this, allowed to make this operation any number of times. Pick two different unmarked indices ing such that 2 times of nums of I is always less than equal to the nums of j, and then mark ing. Return the maximum possible number of marked indices in nums using the above. Okay, so what we have to do basically, we have to pick the two indices I and j, and if it is following this condition, we have to mark them, and we have to give the uh, possible number of basically twice the possible number of pairs which will be able to make, right? So what the first approach comes in your mind when you see this types of question? Right, first approach should come that maximum we can make the n by 2 pairs, right? In best case we can make the n by 2 pairs. Let me give you the example. Suppose we have four elements a, b, c and d. So in best case, what will be our answer? I guess in best case my answer will be the a will make pair with c and B will make the pair with D. It will be the most optimal condition, right? Someone might ask that the A will make the pair with B and C will make the pair with D. In that case, also the A will always make a pair with C and B will always make a pair with D in the best case scenario, right? And we can also see for the odd number, right? For odd number, let's say an E. Okay. So here also what the maximum number of pair we can make. Here we can also make the maximum number of n by 2 pairs, right? So we can say that the A will pick either pair with B or C or D, C, D, any three of one, and one of the answer is that this will make pair with this. So we know that the maximum number of pairs is possible is n by 2, and we cannot make the pair more than n by 2. So if we know that the maximum number of pairs is n by 2, then uh, if if I have the number A, B, C, D, and E, and this is in sorted order, assume that these numbers are in sorted order, and I have put my first indexing in this and second indexing this, right? Because in best case, this two will form a pair, then it will increase the we will increase the pointer I to here and J to here, and this two will make the pair, and our answer will be two pairs, right? So this is the best case scenario, and in worst case, what our answer will be always less than n by 2, right? It will either answer greater than or equal to n by 2. It means what? Our pairs will match in this manner only, right? So let me walk you through the code for the better understanding, and because the approach was pretty much straightforward, right? I will show the two approaches which I discovered while solving this question, right? So first approach was to to use the two pointer only, right? And I believe this approach is most efficient one. So let me just walk you through the code. First, I have shorted the numbers, right? Because I have to make the pairs, and as I have discussed or mentioned today that if this is the format, and then best case scenario, this will make pair with this, and this will make pair with this. This will only possible if these numbers are sorted order, right? So we will sort the numbers, and I have assigned n as the size of my array, right? And what we have just discussed, that in best case scenario I will start from the 0 and j will start from the n by 2. In this case only we will make the maximum number of pairs, right? So I have done that only. I have initialized my j to n by 2, initialized my I to 0, right? And initialized my answer is equal to 0, and I have run a while loop, right? While my j is less than n and my I is less than n by 2, because my I starts from here and J starts from here, and my I, in most ideal case, my I should end here, right? My I should not move out of here, right? It is the maximum value where the I can reach to make the maximum pair, right? So I have what I have checked here. So let me explain this part. Suppose we have a number, suppose 2, 4, 6, 8. Okay, so this is the number. Our I will initially here, our J will initially here, okay, at 0 indexing and second indexing respectively. Okay, so I will increase my jth pointer till it is not following the condition which we have provided. Why I am doing this? Because let's say I have a number a, b, c and d, and my I is here and my j is here, and suppose a is twice is greater than twice the c, basically 2 of C is greater than 2 of A is greater than C. It means what? These two will not able to make the pairs, right? So if these twos are the A and C is not able to make the pair and B is greater than A, then B and C will also not able to make the pair, right? So no need to check for this also. I will just increase the J here and again I will check whether A and D could able to make the pair. If it is able to make the pair or not, then we will further move according to the condition, right? That I have checked the point till my the j is smaller than twice the I, and if it is greater than twice the I, or it will end to end of the array, I have just this condition will get false and I will move out of this loop, right? And what I have checked here, that if my j is less than n, and if it is less than n, and uh, and if it is come out of this loop, it means what? If two times of nums of I is less than equal to nums of j, so it is the one of the pair I have encountered. Sorry, it is the pair, one of the pair I have encountered, and I will just simply increase my answer count of my count or answer by 1, and I will move the I forward and I will move the j forward, right? Let's just see a sample case for better understanding. Let's say it's a 2 3 4 and 5, right? 2 3 4 5. Basically first we will short this array. If we short this array, it will be 2 3 4 and 5, right? Our I will be here, our j will be here. Okay, we will run this loop while 2 is less than 4, because n is equal to 4. Okay, so it will check what? While 2 is less than 4 and 2 times of num is greater than I, increase the j. So it will check what? 2 times of 4 is greater than 4. No, it's not. So it will come out of the loop, and now my j is equal to 2 and I is equal to 0. Okay, it is also following this condition. So what will happen? My count of the answer will now become 1, and j will become 3 and I will become 1. Again my loop will run, right? It will again check. Sorry, my I will be here, my j will be here. Again it will check whether j is less than 4. No, it's not. And it will check if j is less than 4. Yes, it is. Sorry, it's the correct condition. And it will check whether 2 times of 3 is greater than 5. Yes, it is. So it will do what? It will increase the count of j by j plus plus. So now j will become what? J will become 4, right? And once it get become 4, this condition will not satisfy and it will break out of this loop. And now it come here. It will check what? If j is less than 4, no, it's not. So it will comes out of here, and this condition will false and the loop will end, right? So what the maximum number of pairs we have encountered? We have encountered the only one pair, right? And what will be our answer? Twice the maximum number of pairs which we have encountered, right? So it is the basic straightforward approach. And still, if you have doubt in this approach, then you can do a dry run with any other sample test case, and you will get to know that uh, this is the approach and we can move forward with this. The key takeaway and the idea was the maximum number of pair which we could make n by 2. So if we put the maximum number of pair n by 2, then the most optimal condition, my first indexing will make the pair with the n by 2 plus 1th indexing. Okay, that's the most optimal condition, and accordingly we have to move. So the time complexity of this approach will be O of n, as it is we are looping only the one loop. Okay, and j will run from the what 0 to n at max, right? So the time complexity of this code is O of n. Now let me walk you through the second approach, and second approach is binary search approach. Here we don't have to apply the binary search on the array itself, but we have to apply the binary search or answer, right? We know that our answer will exist from where? 0 to n by 2, where n is the size of our answer, right? Because in maximum case we will make the able to make the n by 2 number of pairs, and in worst case we will able to make 0 numbers of pairs. So if this is clear, then we can move forward. So I have set my low to 0 and high to n by 2, and I have run the binary search here. I have calculated the mid. So I have calculated the mid, and is possible function is given me if the mid number of pairs are possible or not, right? If it is possible, then I have updated my answer with answer comma mid, with the what is the maximum of my previous answer and my current mid, and I have increased my low to 1. Let's just do the dry run for the better understanding, right? So it's suppose it's a 2 4 5 and 9. Okay, so I have shorted the array similarly here, right? So it will be what? 2, 4, 5 and 9. So n is equal to what? 4. N by 2 is equal to what? 2, right? So my my high will be equal to 2. So uh, my high will be equal to what? High will be equal to 2 and low will be equal to 0. The mid of these two is 1. I will ask the is possible function. A is possible function. Tell me whether it is possible to make one pair or not. So we know that we could easily make the one pair, right? If we see here, then these two is a pair. So yeah, we can make the one pair. So if it is possible, then I will update my answer with my current and maximum of current answer and previous answer. And if if we know that we could make the one pair, then what is the other possible condition? Like my now I know if I could able to make the one pair, then my answer will lie from the mid plus 1 to high, right? Basically from 2 to 2 in this case, right? So again I will check here that hey is possible function, tell me whether it is possible to make the two pair or not. If it is telling yes, we could make the two pair, then again I will update my answer with 2, right? And I will shift my low to what? Low will become now 3. Now again it will check whether the high is greater than equal to low. No, this condition will false and it will break out. And suppose there's a suppose we calculated the mid here. Let's say it's equal to k, right? Or whatever the k1 value. Okay, and I have asked the is possible function. Hey, is possible function, tell me whether I can make the k number of pairs or not. And if it is saying no, we cannot make the k number of pairs. Okay, then we know what my answer will lie from where? Low to k minus 1, right? It is the range of my answer. Now the range of my answer will shrink now, right? Let's just see how the is possible function is working, right? Suppose so it is also based on the same concept which we have discussed previously, right? If we are passing the value of k, suppose it is equal to 2, and we are asking whether tell me whether the two pairs are possible or not. So what it is doing that, suppose this is the number of size of the array is 5. Okay, so 2 will come here. So in most optimal condition, or the one of the condition of the answer is will be what? That these two will make the pair from any of the two from here, right? Because if the answer is possible, then this condition should always satisfy, because the two smaller number will make the uh, pair with the rest of the number, right? This is the condition. So this thing is only checking here. This function is checking here. What it is doing here? It is setting the I to 0 and my j to here, the k, where basically the k will be 2. And I have and why have what I have checked? Is I is greater than equal to k, means what? I is here. If I could get the I to here, it means what? These two got their pair respectively. These two got their pair, means this number of pairs are possible. So, and if this number of pairs is possible, then we have to just return true. So that's only thing we are doing here. And so if I is greater than k, then we have just to break, right? And it is checking what? If nums of j is greater than the 2 times of nums of I, then I will increase the I. Basically, if a comma b is a possible pair, then what we have to do? We have to shift the I here, and we have to shift the j from here to here, right? And if it is not a possible condition, then what we have to do? Then I will, sorry, so I will remain at its old place, right? And j will move forward, because if these two are not forming a pair, this means what? That my I will remain here and my j will remain here. Basically, it's a two-pointer approach, and we have to find the we are just doing that if I reach to the end of its condition and j also reach to the end of the condition or not. That's not our concern. The concern is that I reach the end of its condition and it will reach to the end of the end of its condition. Basically, I reach to the k when k number of arrays are possible, and we have solved this with using a two-pointer approach. Let's just do a dry run for that also. It's 2, 5, 4, and 9. So we have first searched for the n by 2 for the 1. Okay, because n was equal to our high was equal to what? 2. The mid was equal to 1 in first iteration, right? So I have to check whether we can make the one pair or not. My I will be here, and my J will be here. What J will be at this point, right? Sorry, J will be here. It will check whether these two could make a pair or not. If these two can make the pair, yes, these two can make the pair because 4 is because yes, we could make the pair uh, because 4 is greater than equal to 2 times of 2, right? So it will make the pair. Then I will move to what? I will move to 1, and J will move to what? J will move to 2. So I have checked the condition. If I has reached to k, means if all k numbers got their pairs, it means what? Yes, k number of pairs we can make. So just we have simply written true, that if I is greater than equal to k, yes, it is greater than equal to k, then it will return true. It means what? Yes, we could make the one pair, right? So if we could make the one pair, so my now low will be equal to what? 2. My high will be equal to what? 2. Again, again the is possible function will pass with the f of, let's say, is possible 2 comma nums, and nums is sorted here, right? So again it will happen 2, 4, 5 and 9. My I will be here, my J will be here. Again these two, yeah, again it will check what? If 2 times 2 is less than equal to 5, yes, 5 is greater than 4, so I will move here and J will move here. Again it will check what? That 4 times 2 is less than equal to, or 9, yes it is. Then again my I will move here and my J will move here. This condition will trigger, is I is greater than equal to k, yes, because my current value of I is equal to what? 2. So I is 2, and it is whether it is greater than equal to 2, yes, it is greater than equal to 2. So it will break out of this part, right? And it will break out of this part, this entire while loop, and it will again check here whether it will return 2 greater than equal to 2, yeah. So it will return true. We will receive true here. So we will receive true here. So our answer will be what? 2, and our low will be equal to 3. My high is equal to 2. The loop will break, and it will return my final answer is equal to 2 times the number of pairs, which is equal to 2. So 4 is the answer. So this was pretty much straightforward approach. Let's just see the complexity of, basically the main takeaway was here that the maximum number of answer is n by 2. Whether you solve this with the sliding two pointer approach or apply the binary search on the answer itself, you will get the answer. So the time complexity of the binary search approach was O of n log n for the binary search, and for each binary search we are running the sliding window or the two pointer. So it will take the O of n time. So total it will be O of n log n, and for the two pointer only approach, the time complexity with O of n. I hope I could able to make you understand the question. If you have doubt, then feel free to ask, and I would highly suggest to do a dry run at once. And yeah, this was pretty much from my side. Thank you and have a nice journey.